Right, so our last lesson, we were basically just talked about forces, didn't we? We didn't really do much because we'd just gone through the test. So we just talked about, we use Newton balances to measure forces, and forces can change the speed, just copy that, speed, direction, and shape of an object. Okay, so today we're going to sort of put forces into a little bit more content. Okay, so the Earth's gravity. So why do objects fall down when we drop them? So many people might answer this question by saying because of gravity, but we're going to look at that in a bit more detail. So I asked you to have a quick look at these questions. So consider hanging an object onto a spring that is held vertically. So just hanging at the end of a spring. What do you normally have to do to make a spring stretch? Yeah. You can attach an object to it or pull it. Yeah. It's not a trick question, it's just as simple as that. You can just pull it, yeah? So we know that pull or pusher forces, aren't they? So you can pull it, you can apply a force to it. So what causes the spring to stretch when the object is hanging from it? Yeah? Yeah, the gravitational force pulls it down. Yeah. So that is basically what gravity is. The gravitational force pulls things down, and it basically pulls it down to the very center of the Earth. And everything that has got mass, so everything like you guys, everything in this room, anything that's got mass, does apply a little bit of a force towards it, but because we're so small compared to a planet, don't really feel it. Okay, but the Earth has obviously a bigger gravitational pull than we do. So what the Earth does is it has a gravitational pull towards the center of the Earth. So it's always towards the center of the Earth. So the Earth exerts a pulling force on all objects. The force is due to Earth's gravity. Although we may not realize it, we experience the force due to the pull of gravity every day. For example, you feel it every time you lift your school bag off the floor because you are pulling it against the force of gravity. So gravity pulls objects down, and no matter where you are on Earth, gravity pulls objects down. It pulls it to the center of the Earth. Okay, so even if you're in Australia, you get pulled to the center of the Earth, so it's basically like that. Okay, so all objects on Earth, including us, are being pulled towards the center of the Earth. So the differences between weight and mass. Now you did do this in first year, but you may have forgotten it. So definitions of weight and mass, really important, will always trip somebody up. Okay, so weight is the force of gravity acting on an object, and it's measured in newtons. And weight is measured with a Newton balance. And mass is the measure of amount of matter in an object, and it's measured in units called kilograms, and it's measured using a scale. Now, we always get confused because the English, basically anyone who speaks in the English language will probably say, I'm measuring my weight by standing on a scale. What you're actually doing is measuring your mass. So, like Weight Watchers, when people go to Weight Watchers and try and lose weight, what they're actually trying to do is lose mass. So it really should be called Mass Watchers, but it doesn't quite have the same ring to it. Yeah. Yeah, so technically, if you weigh something, you have to use a Newton balance to weigh it. That's a good question. I don't think there is one. Yeah, I mean, there should be one. Finding the mass is probably, measuring the mass, but there isn't like a shorthand way. There should be, but there isn't. But yeah, and as you point out, I say, even as a physics teacher, I say, I'm weighing this, I'm going to weigh that, but actually what I'm doing is measuring the mass. If I'm baking, I'll weigh out some flour, but I'm measuring the mass of the flour. Yeah, so just be careful. It's really easy to get mixed up because everybody does. Okay. Right. So, have a think about the following questions. So, do you think that the force of gravity, i.e. the weight, is the same for all objects? And explain how you measure the weight of an object. Well, we just sort of went through example 2. So we could do example 2 because we just talked about you use Newton balance. But have a think about question 1. I'd normally say, you can chat amongst yourselves. I suppose, Logan, you could turn around and That's a Rory. Just have a discuss it between yourselves just for now, and then we'll do it as a class. Okay, has anyone come up with anything? Yeah, go on. Yeah. You hear that, girls? So I'm saying, no, they're not the same, because if you've got something with a bigger mass, then it takes more of a force to sort of lift it up, or for it to more of a force downwards that it has. Okay, so just think about even when you're picking up like a bag. Okay, so if you're picking up your school bag with all your books in it, it takes a bigger force because it's a bigger mass. Okay, so it's got a bigger force downwards. Whereas if you're picking up a bag with I guess you're just peek it at it with less mass, so it's less force downwards, so it takes less force to pull it up. Okay, so do you think that the force of gravity is the same for all objects? No. Objects with bigger masses apply a bigger force downwards. Right, so we are going to do an experiment. So we're going to measure the weight of an object. So we're going to use Newton balances to measure the weight of an object. So aim to investigate the relationship between the weight of an object and its mass. So what we're going to do is, I'll show you, I have got my camera set up, mostly for the people at home so they can see what it is. So I've got a Newton balance here, and it goes from 0 to 10. And I'm also going to use some 100-gram masses. Okay. So what I'm going to do is simple as pop 100 grams on and read off what the scale is. Okay, so that one is about 1. Okay. You did it in S1 as well, yeah. So we're going to do that, and then add. So remember, the holder itself is 100 grams. So then you're just going to add 100 grams on each time and read off the weight. Okay. Just be careful with your clamp stand; it does tend to tip over as you get to the higher masses. Okay. So you will need. We'll go back. We'll draw the diagram in the booklet, and then we can have a go. So you will need a clamp stand. Spring balance or Newton meter. Remember, it's the same thing. And slotted masses. They're called that because they slot into place. Okay, so start with 100 grams and measure the weight. Add 100 grams and do the same. There's not much to it. Your results table, you'll see it's got mass in kilograms. So how do you change from grams to kilograms? Yep, divide by 1,000. So, for example, 100 grams will be 0.1 kilogram, 200 grams will be 0.2. Weight is what you're reading from your spring balance. And then the last one, weight divided by mass, which is in newtons per kilogram, newtons kilogram. So it's just basically get your calculator out and do weight divided by mass. So my first one was about 1. So it'll be 1 divided by 0.1, which is, yeah. Yes, because it's named after a person, yeah. Sorry, where? Yeah. Oh yeah, sorry, yeah, add, yeah. Yeah, my handwriting, yeah. So my weight divided by mass for my first one would be 1 divided by 0.1, which is 10. Divided by 0. You don't have to write the sums each time, but just to remind you what that is. Okay. When you're ready, equipment, class stats are in this cupboard over here, the rest of the equipment's over there. Just be careful of it toppling over. If you're doing it on your own, just make sure you're holding it down. I'm going to upload